Oxygens in group 6. Group 6 nonmetals are -2. Group 7, -1. Group 6, -2. Group 5, -3. -2 times 2 is a -4. We need to cancel -4 with a +4. And that's the function 10. Positive 4.
So whatever oxygen is, 10.
As we did.
Whatever oxygen is, 10. The same amount of oxygen.
What the total oxygen is. Because oxygen's a -2. 10 is a +4. Well, we have two oxygens. So it's not whatever oxygen is, it's the total of all the oxygen.
And it's just positive for them. Is it always like that?
No. Because right now we only have one 10. What if there were two 10s or three? Then the charge has to be spread out. So, so this top one is iron 3 oxide. -2 times 3 is -6. Cancel that with a +6. But we have two irons. So 6 divided by 2 is 3. So it's not iron 6, it's iron 3. Here, then -2, there's only one of these, so to cancel -2, you just need a +2. So that's an iron 2. So it doesn't, depending on how many you have here, if there's only one, yes, it has to be whatever that is. But if you have 2, 3, 4, then you have to divide it. Just write out the charge. So SN2, excuse me, SNO2, it's 10-4. Oxide. You know, the beginning is the same as what we're doing on Tuesday. Name the metal, iron, name the non-metal, chloride, iron oxide, copper phosphide, chromium bromide, tin chloride, lead sulfide, bismuth chloride. So name the metal, name the non-metal, make sure it's an IPE. And then check, is the metal in groups 1, 2, or 3 zinc, cadmium, or silver? If it's not, then we have to add the charge in parentheses. Has to be calculated. -1 times 2 is -2, cancel that with a +2. And then like we just did right here, -2 times 3 is -6, cancel that with a +6, 6 divided by 2 is 3. Group 5, non-metals are -3, so that's -3, -3 times 1 is -3, cancel that with a +3. 3 divided by 3 is 1. So copy that. Group 7, -1 times 2 is -2, cancel that with a +2. So copy 2. SnCl2. -1 times 2 is -2, cancel with a +2. Sulfur's in group 6, like oxygen, it's a -2. -2 times 2 is a -4. Cancel that with a +4. -1 times 3 is -3, cancel that with a +4.
On the test, we're gonna cover all of chapter 6.
And 7.1.
So Roman numerals.
just indicate the charge they want them in Roman numerals. That's just, so it would just be 1 through 10. Or it could go higher.
No. So working backwards. Working backwards, then you just need to find out how many of each you need. So this is iron 3. That number is the charge.
Okay.
You don't look up iron on the periodic table. I don't know what charge it is because the periodic table doesn't have this out. That's why it has to be included in the name. So iron 3, that's what that 3 is. Chlorine, that's in group 7. Group 7s are -1.
Oh.
How many -1s to cancel a positive 3?
3? Okay. Oh, okay.
If we see it.
Okay.
So if you have the name and you see a number in parentheses, that's a charge. If you have an ionic compound and you do not have a parentheses, then that means that metal is in 1, 2, or 3, or it's in cadmium or silver. Because those we're supposed to know what they are. Group 1 plus 1, group 2 plus 2, group 3 plus 3, zinc and cadmium plus 2, silver plus 1.
So,
So nickel 2 sulfide. So it's a nickel plus 2. That's what that Roman numeral is. Sulfur's in group 6. Group 6 are negative, non-metals are -2s. Positive 2 and a -2, they cancel each other out.
oh, so you just write it like, okay.
And like this.
Yes.
Group
So,
1 plus 1, group 2 plus 2, group 3 plus 3. There's 3 that you need to memorize. Zinc, cadmium, and silver. Silver's a plus 1. Zinc and cadmium are 2.
zinc, cadmium, and what?
Silver.
Silver.
Zinc and cadmium are plus 2. Silver is a plus 1. That one you just have to remember. How many -1s to cancel a positive 2?
2.
And then iron 3 oxide is Fe plus 3 because that's what the 3 is telling us. Oxygen's in group 6. Group 6 are -2s. Lowest common multiple,
Oh, that's right. Okay.
lowest common denominator is 6. How many 3s to get to 6?
2,
How many 2s to get to 6?
3. Oh. Okay.
So the other handout that you're going to use in your exam is called common polyatomic ions. So that's what this section is. So right now we've been looking at metals that have positive charges, not metals that have negative charges, but these are elements that gain lose electrons and end up with a charge. Well, groups of elements as a group can also gain or lose electrons and become charged particles. But because they're a group of atoms, then they're polyatomic.
Groups of atoms?
Poly meaning more than one. So sodium chloride, NaClO2, is used in processing and bleaching of pulp, wood fibers, and recycled cardboard. Your ClOs are your bleaches. ClO, ClO2, ClO3, ClO4. They're all very strong oxidizing compounds. And ClO2 is one of those polyatomic ions. A group of atoms with an overall charge. The most common ones, at least in the body, will contain a nonmetal, like phosphorus, sulfur, carbon, or nitrogen. Rest of the body, though, will encounter quite a few that contain metals. Most of them will have a -1, -2, or -3 charge. There is one, well, actually there's two. Positive polyatomic ion that you need to be aware of, and NH4 is ammonium. The other one is actually mercury 1. Mercury 1 comes in twos. Actually, I'm gonna skip over it. So you'll see it here, and that's just mercury 1 ions form an ion pair with a positive charge. So they don't come single. Okay, they always come in twos. So it's either 2, 4, 6. That's it. So that one and ammonium are basically your two positive polyatomic ions, but the important one is ammonium. Okay, all the other ones then have a negative charge. Either -1, -2, -3. If you look through that chart for your exams, you'll notice that they're all -1.
You said an ammonia and which other one have a positive charge?
Mercury 1. Here comes as a pair. So in this example, we have calcium sulfate. Sulfate is a polyatomic ion. We have a nitrate, ammonium nitrate. Nitrate is also a polyatomic ion. Most of the polyatomic ions end in either ate or ite. ATE or ITE. So as we go through this list, nitrate, nitrite, chlorate, chloride, chloride, carbonate, acetate, sulfate, sulfite, sulfite, phosphate, phosphate. Almost all of them end in ATE or ITE. This is helpful when working from name to formula. If you're given the name of an ionic compound and it ends in ate or ite, then you know to refer to that handout, to that table. So you're going to find the negative component. If it ends in IDE, then most of the time it will be a non-metal. The polyatomic ions that end in IDE now, both of these columns contain the same components. This is alphabetical order by name. This is alphabetical order by form.
Oh, that's nice.
It repeats. Okay, so just take a look at the names since we're looking for IDEs. And there's 5 of them. A site and 3 with a -1. Okay, that's an IDE. Cyanide, Cn minus. Hydroxide, O minus, peroxide, 2 minus. Okay. And then this is special one, thiocyanate, is C minus because this is also called thiocyanate. And so those are polyatomic ions that end in IDE. So SCN minus full names are
All right, thank you.
accepted names. Thiocyanate or thiocyanate. Okay, so everything else that is in IDE, you should be thinking non-metal. So sulfide means sulfur, phosphide means phosphorus, oxide means oxygen, nitride means nitrogen, chloride, chlorine, chloride, so on and so forth. Okay. Except for these 5 right here. And it's kind of helpful that they don't have a name that sounds like any element. So there's no element that begins with AZ. There's no element that begins with CY. Other than hydrogen.
And because they end in IED, that means what again?
Well, these are the exception to the rule. The rule is if it's IDE, it's a non-metal, except for those ones. Right.
So you will be given a name, and then you have to come up with a formula. So if that name ends in H or IT, use your handout. If it ends in IDE, you should be looking at the periodic table. These are the exceptions. If you don't look at the periodic table.
What did you say the other name for thiocyanine is? Thiodine?
Thiocyanate.
Thiodine? Oh,
So the
8.
curve next to the three. Now, since all the other ones end in 8 or I, there are some patterns. Okay, so we can see. Your 8s for the same, when the beginning part is the same, so they're kind of like families. So here we have a nitrogen family, NO3, NO2, CLO, so these are CLO. S and S, phosphorus and phosphorus. Okay. The 8 will always have more oxygens than the 9. For any given family, those that end in ATE will have more oxygens than those that end in ITE. So nitrate has 1 more oxygen than nitrite, chlorate has 1 more oxygen than chloride,
Oh.
phosphate has 1 more oxygen than phosphate. And so there are patterns.
So is that a way to check?
Kinda. I mean, I would rather to just make sure and look at it. You know, as you're getting to know them. So, you know, look it up on the handout. There's nothing wrong with looking. Like
Yeah.
that. You know, it's the safest way to make sure that you have the right one.
Now, question on our handouts and stuff like what I do is I'll take things from the book or things like this. Can I put that on the handout to use on the test? Yeah, like anything on the slides, right, is fair game and book?
Anything that you think will help you out.
Okay, good. I don't want to feel like I'm cheating or anything, you know?
No, the material is hard enough
Yes.
as it is. I don't need to make it. more difficult. And in real life, it's not.
You don't need to know it membrane.
I mean, when you work in the, whatever field you work in, you know things and memorize things because you're using them on a daily basis. And then, so we memorize this through inertia because we're seeing them all the time. You know, but it's not like the book I have to memorize. It's just do it, you know, like a song that you listen to all the time. So, again, those that are not memorized, well, we look them up.
It's true.
Now there's Google.
Yeah.
You know, before we had there's still, and then at the library they have a couple of volumes of something called the CRC Handbook. And there's a CRC Handbook for chemistry, there's a CRC Handbook for physics. CRC Handbook for chemistry then contains a lot of information about the elements, about compounds, melting points, boiling points, rules for naming compounds. And so like we used to. It wasn't like required for a class, but you know, everybody that was going for chemistry had one of those because you knew you were putting these all the time to look these up.
Oh, wow.
You know, now you have Google and stuff like that.
Yeah, my farm teacher would let us use drug cards, but the only deal was that we had to make them ourselves. We couldn't buy them. Because she says as a nurse, you don't use drug cards, you just Google it. And then you just get the answer to the drug that you're...
Yeah, now I mean, you would see, if you're a nurse, you would very,
discreetly
a
Google
drug,
it.
and not so discreet, but you would have, I mean, if you were smart enough to know that you don't know everything and that you can't remember, you would have a drug book in your pocket.
Yeah.
And then drug book, then things that, drug names that sound very similar,
Mm-hmm.
or even to check dosages for adults, kids, things like that.
Yeah, we were allowed to use the drug book, but they come electronically now, so that was easier.
There's an app for that.
Yeah, exactly.
So, okay, now, well, we try to stay away from common names. There are some common names that are so ingrained that we do need to be aware of. Okay, so these that begin with hydrogen. Okay, so basically, hydrogen is a positive one ion. So anything that's -2, -3, you can create another ion by adding 1 or 2 hydrogens. So we have phosphorus. So we have phosphate, phosphite, sulfate, sulfite. So it's our -2s, -3s. So we can add a hydrogen, and then that decreases by 1. And then we end up with hydrogen sulfate, hydrogen sulfide. These are still ions. Okay, for the -3s, they become -2s, and then you can add another hydrogen, become -1s. Okay. Well, for those, okay, so all of these right here that begin with hydrogen, okay, the word hydrogen in common names is replaced by the prefix by. So that hydrogen carbonate is also called bicarbonate.
Oh,
Hydrogen phosphate is also called biphosphate, hydrogen phosphide, biphosphite, hydrogen sulfate, bisulfate. Bi does not mean 2. Bi means hydrogen.
okay, fine.
So all those that begin with hydrogen, and just hydrogen, not dihydrogen, okay, just hydrogen. You can see those polyatomic ions in either form. Either the hydrogen name or instead of hydrogen, the prefix bi. Okay. So we go down the list. Bicarbonate, biphosphate, biphosphite, bisulfate, bisulfite, bisulfite. Those are used and acceptable names for those polyatomic ions. So the table gives you the name, the formula, and the charge. So that handout has all that information, the name, the formula, and the charge.
When it's written out biphosphate, do you put space and then the name, or is it together in one name?
No, together in one.
Sorry, okay.
So it'll be,
Biphosphate, okay. Oh, okay, I see, okay.
it'll be one word. And remember, there's 5 that end in ID, then divided in each, all right? And then if you put the hydrogen, then it's 5. Either of the two. So sodium bicarbonate is NaHCO3.
Mm-hmm. That's nice.
Sodium plus 1, group 1, bicarbonate is a negative 1. So they cancel each other out.
Oh, wait, do that again? You went too quick.
So this is the bicarbonate of polyatomic ion.
Okay.
And as a group, it has a negative 1 charge.
Oh, it's a group. Oh, okay, okay.
So all of these groups, that charge is for the whole group. Do not multiply the charge by the number of oxygens.
Okay.
So it's group.
So that negative 2 is for the whole thing. Do not do negative 2 times 4.
Oh, okay, I'm glad you said that.
So, when writing formulas or names for those that contain these polyatomic groups, if you got the formula after the metal, look everything that comes after the metal. Look it up on that handout. And whatever name that handout tells you it is, that's exactly the name that you write down. Do not change it, do not modify it.
This is getting.
If you have something in parentheses, like a nitrate here, then look for what's inside the parentheses. Okay? You can ignore what's on the outside. So you would look up at O3, that's called nitrate. That's it. You would just write nitrate there. So if it's a nonmetal, you write the name of the nonmetal and make sure it ends in IDE. Well, if it's a polyatomic ion, just write the name of the polyatomic ion, period. No other changes. Now, when you're coming up with a formula, since the formula needs to be balanced, if to balance the formula you need more than one polyatomic ion, then you need to enclose it in parentheses. So here we have magnesium plus 2, because it's a group 2. Nitrate has a negative 1 charge, so you need 2 negative 1s to cancel the positive 2. So we need to indicate 2 nitrates. So to indicate 2 nitrates, we put the nitrate in parentheses and the 2 on the outside. If not, it looks like NO32.
Oh. Oh, 2 sets of that. Okay. I see what you're saying now.
Yes, do not break up the group.
It's mathy, but it's not. It's weird. I don't like any of this. At all. Like, at all.
They come as a unit, and that's it. And this is, we still have the same puzzle pieces. So say we have chloride with a negative 1. Well, now it's nitrate. But it's still one group.
Okay. But in this case, it's 2, isn't it? 2 groups.
To balance it.
Oh, to
So
balance
it
it.
would be to,
You draw
the
another
puzzle
one.
pieces is still a negative 1.
Yeah.
Now it depends on what you're combining it.
Oh.
So if you're combining with a positive 1, you're combining with a positive 2, then yes, you would.
You would need to. Okay. Get it.
Here,
Ugh.
we're going to need 3. So aluminum bicarbonate. Aluminum is in group 3, so it has a positive 3 charge. Bicarbonate, it ends in AT, so you would look up bicarbonate on the handout. Okay, or you're going to find bicarbonate, remember it means hydrogen, so we look hydrogen carbonate. Once you find that, then you write that down. So on your handout, hydrogen carbonate is HCO3 minus. So we have a positive 3 and a negative 1. We need 3 negative 1s to cancel the positive 3. So we need to include it in parentheses. And then put a little 3 on the other side. So we put the part in parentheses.
So, okay.
And they're always, the charges are always balanced.
Yes, and I'm counting all this out.
That's why you put the parentheses.
Sodium is in group 1, that
Okay.
means it's a +1. Phosphate, it ends in ATE,
Let's look at
so we look
that.
it up.
Down.
So we look at phosphate.
PO.
So we have a positive 1 and a negative 3. How many positive 1s to cancel a negative 3?
3. Oh, okay. And you just leave that 4 there. You don't do nothing with it.
It's a group, right? It's, this whole thing is a negative 3.
Oh, it just doesn't have the. You don't have to put it down there then?
The parentheses?
Yeah,
No,
Like-
That's how you balance it.
right there.
That's
because
what I was just asking.
we only need 1.
But you just said it. We need 4. It's 4 of them.
No, we only need 1 phosphate.
Oh,
How many phosphates? Not
One.
not how many phosphates, not how many oxygens, how many phosphates?
okay.
The parentheses kind of separate the way it's balanced to how many it has in the whole.
No, yeah, but I get it. I think. I think.
Three, 4. We're naming, so reverse, from name to formula. Simply name the metal, and then if after the metal comes a group, look up the name of that group. You just write it down exactly as you see it. If the metal is not in groups 1, 2, or 3, and it is not zinc, cadmium, or silver, then you need to include the charge using the Roman numeral. So Na2SO4. So Na is sodium. After the metal comes SO4. So you would look up SO4 on the handout. Once you find SO4 on the handout, it tells you it's called the sulfur. So just straight sulfur. Sodium sulfur. That's in group 1. We do not need the Roman numeral. Iron. Then you look up PO4 on the handout, and that tells you it's called phosphate, so it's iron phosphate. Then we check it to see if we need a Roman numeral. Iron is not in groups 1, 2, or 3. So we need a Roman numeral. Now, it has to be calculated. So when you find phosphate from the handout, what's the charge on phosphate?
Negative.
Okay, so what does iron have to be to cancel a negative 3?
3.
It's iron 3.
So it's just the way you wrote it here, but with the Roman numeral.
How do you know if you need to calculate it? Because if it's a negative and a positive?
When you're going from formula to name.
Like for me. Because you said if metals are not in group 1, 2, or 3, then you don't need a Roman numeral.
And iron is not in group? Oh, okay.
It's not in groups 1, 2.
Okay.
So on that, on Tuesday, I gave you 2 choices for positives. Monovalent, multivalent, 2 choices for negatives. Monatomic.
Okay.
The ones that need Roman numeral are the ones over here in blue. The ones that don't need one are the metals that are here.
Okay.
You took a picture.
Yeah, I'll watch the video again. And have it on repeat.
So aluminum. Now, if you see something in parentheses, look up what's inside the parentheses. So you will look up CO3. The
Okay.
handout then tells you that CO3 is called a carbon. So just write carbon it down. So aluminum carbon,
And aluminum's in what group?
group 3.
3? Oh, so
So we do not
it's
need
real
it.
nice. You don't need it. Okay. Ugh.